Hi, this is Electronics. In this video I will restore and modernize this old Sony speaker pair. If you enjoyed this video, then don't forget to subscribe and press the bell to get notifications of my new uploads. These are the planned improvements I want to make on these speakers. First, I will change the tweeter with a high quality silk dome tweeter from AliExpress, which was presented in an earlier video. Then the speaker wires will be changed to a greater quality wires dedicated for speakers. New crossover circuit will be designed and made dedicated for these speakers. Last but not least, the speaker protection cloths are badly damaged, so they have to be changed too. Let's start with the first step. The old tweeter is in a bad shape and it's not a good quality tweeter, so it is time to remove it. The woofer is also removed in order to access the wires to cut them. This is the old tweeter. It has an Elna 1.5 microfarad 100 volt rated bipolar capacitor connected in series, working as a high pass filter. The new silk dome tweeter fits exactly in the hole, but there is no surface to mount to. To solve this issue, I've cut out a circle of laminate floor piece using drill crowns. I put tape on another small piece of laminate floor, which will be used to make this circle sit flush with the inside part of the speaker box. The tape prevents this piece to stick to the glue and makes it easier to remove after gluing. When everything was prepared, I've used a D3 type wood glue, which is very strong, to glue the ring to its place. Toothpicks were used to center the ring in the hole. After a day of cure, I've cut down the excess of the toothpicks and put more glue to make sure that it will be a strong bond. In the remaining holes where the old speaker screws were used, I've used also toothpick and glue to seal them. Sealing every possible leakage will increase the speaker's quality. I make markings and drill holes for the new tweeter screws. Now that the speaker box is prepared for the new tweeter, it's time to prepare the box for the new speaker wires. The speaker wires will be connected directly to the crossover circuit in the box. This means that there will be no binding posts. This way unwanted losses and magnetic interferences are eliminated. Now that the tweeters are replaced, a new crossover circuit is needed. The 1.5 microfarad capacitor connected to the tweeter is not a proper crossover. To design a crossover, driver measurement data is needed. One is driver impedance data, which is the ZMA file, and the frequency response data, which is the FRD file. Driver impedance data can be measured with DETS version 3, which process you can learn in my DETS version 3 review video. Frequency response data is made by using a calibration mic and Room EQ Wizard software. Here you can see and hear the measurement of the woofer and the tweeter. After all the collected data, the crossover can be designed in the XSIM software. This is how the response curve would look only with the original 1.5 microfarad capacitor connected to the new tweeter. You can see that the crossing point is around 9 kHz, which is too high. The woofer would have to do the most of the work, and the dome tweeter would be used only at around 30% of its potential. So I've started to design, and here is the first crossover circuit design, which was rather simple. I had no coil with these parameters, so I had to hand make them. I've used the Coil 64 software to calculate the winding number of the coil. I've also made the PCB for this crossover. The PCB was made in Manhattan style, so the copper plate was cut to make the traces. After the listening test it was good, but there was some kind of distortion. I've asked DeepSeek AI for help in designing the crossover, and to my surprise it was really good at this. According to the AI, the woofer has a breakup point at 4.5 kHz, which is audible and has to be cut. The woofer breakup is a frequency range where the speaker cone vibrates in an unwanted way. The outer edge of the cone cannot keep up with the center and can bend, ripple and create unwanted resonance. It has recommended a low crossing point at around 3-4 kHz and a notch filter to attenuate the woofer breakup, so I went back to the XSIM to implement these changes into the crossover design. This is the final crossover design in XSIM. More coils had to be made and new parts had to be ordered to build the new crossover. Here is a size comparison of the first version and the final version of the crossover PCBs. This is how the finished final crossover looks like. The obligatory measurements were also done and the final results looks promising. I made several measurements to have enough data. Here are 3 measurements and finally a combination of them. The lowest points are at 200 Hz and 1 kHz, and at around 1.2 kHz there's a higher point. As I move the speaker or move objects in the room, this diagram changes. I think the final results are good, and it is a better sounding speaker than an average commercial speaker. A speaker is considered hi-fi when it has less deviation than ±3 dB from a flat line. Mine has a ±4-5 dB at low frequencies up to 1-2 kHz, but these can be created by the echoes of my room. The final step is to replace the speaker protection cloth. Firstly, the Sony logo is removed and then the old cloth. Then the replacement material is cut to an approximate size with some allowance for adjustments. The new cloth is glued to the frame using a plastic tool. After finishing the replacement, I've noticed that I forgot to make the holes in the plastic frame. This plastic frame has some big closed areas on the top part which deteriorates the tweeter's performance. To fix this issue, the big closed area must be drilled so that the tweeter won't be attenuated. Ground drill bits can make big holes, then you can cut out more with a disc cutting machine. You have to make a balance between structural integrity and tweeter response. If you cut out too much, the front plate might get too weak or start to resonate. The speaker is finished. The measurements can show good results, but the most important test is the listening test with music, games and movies. Personally, this speaker sounds and looks really good, a lot better than how it was before, and I'm satisfied with the end results. Now I have to do all this work with the second speaker too. Thank you for watching.